Hi everyone and welcome back to my channel. In this video we will see how to create this interactive map which is showing some cycling routes and some landmarks in a national park in Spain, in Picos de Europa. So this interactive map is using MapLibre and MapTiler, which I will comment in a moment. And if I refresh, we will see the effect of the map, and we also see that this in the north of Spain, and we can have a look at the different components of the map. So in the exterior, we have the polygon that is delimiting the study area, which is the National Park of Picos de Europa. Then we have also line features, which are showing different routes that can be done by cycling. And we can see when we hover over them that we have a message telling us the name of the route and also the length of the route. And you can see also that when I hover the different lines, they become red and thicker. And we will see also how to do this effect. And finally, we have different points which are representing some landmarks, and the pink ones, they are viewpoints, and the others, they can be different things. So I will zoom into this route, which is Lagos de Covadonga route, and I can also rotate it like this using my right click button. And we can see also if we click in the different points the name of this landmark. So here we have the Mirador de la Picota, which is a viewpoint because it's pink. And here we have a white one which we can click also, and we see that this one is called Mina de Buferrera. Before diving into the code, I wanted to explain the differences between Mapbox, MapLibre, and MapTiler. Mapbox is a JavaScript library for displaying maps using WebGL, and Mapbox was initially released in 2010 as an open source software, but in 2020 it became commercial after the release of the second version of this software. And after that, we have some limitations on the use of Mapbox. Although in the previous week video, I showed you one example creating an interactive map using Mapbox, and I showed you that we can create some map requests per month. Then we have MapLibre, which stands for Map Library Restarted, and it was born in December 2020 based in Mapbox GLGS 1.13, which was the latest version of Mapbox that was open source. So this was a work taken by some contributors that wanted to keep this project as an open source work, and they started to work independently from Mapbox. And then we have MapTiler, which is another software or library that extends the functionality of MapLibre. This one has commercial and open source capabilities and is mostly focused on tiles and hosting. And we will use it in this video, and you will see also that it needs an API token, and I will explain you now how you can get this one. If you want to use MapTiler, you need to create an account in maptiler.com. So once you are here, you can go to this button, create free account. I will sign in with Google. And in this case, I already have my account, so I'm already logged in. And here you can see some of the standard maps. You can use all of them, I think, except this one in R, but I suppose this one will be introduced soon. And there are also here other maps. Here you can see the tiles, the data, and you have here your API keys. By default, you will have one, and you will copy it to create an environment variable in your system. So once you have your API key, you can go to edit the system environment variables, and this window that you have here will show up. Then you will press in new to create a new environment variable, and this other window will show up. And here you have to introduce two different values. The first one is the name of the environment variable, which must be maptiler underscore API underscore key, and this name must be exactly like this. You cannot change anything. and then in the other space you will paste your key. And the key, I repeat, is the one that you copied from here. And then you will accept and accept again. And in the case that you have RStudio opened, you must close it because the terminal must be restarted in order to these environment variables to take effect. And last but not least, you must never share your API key with anybody, because if anyone has your key, they can use it to create other maps and they can increase the number of maps that you create per month, and that can be translated into costs for you. And in the case that you accidentally share it with anybody, you can hit here in replace and it will create a new one for you. And if you create a new one, you need to change it again here. Alright, so now we will dive into the code. And if you want to follow along with me, you can find this script in the comments of this video. So I will start loading the packages, and first I will load the pacman package, which is one that I typically use to use this function payload, which will load the rest of the packages and install them in the case that you don't have them installed. So the first package is the archive package that we will use for unrar some files. The fs package, which stands for file system, and we will use it here to create a directory tree. The mapgl is the package that we will use to create the final interactive map. MapView will be used to create some interactive maps also, but it will be just for exploratory purpose because the map view is more straightforward, just for creating exploratory maps. The OSM data package for accessing the OpenStreetMap API, the SF package for vectorial data, and finally the tidyverse. So now they are already loaded into the session, so we will start loading the data. And the data that we need, you can see here that we have three different sections. First, we will load the National Park of Picos de Europa, then the cycling routes that are inside the national park, and finally the landmarks. So we will start with the national park, and here I have this URL that I will show you how I found it. So in Google I wrote Parques Nacionales España SIG, which stands for National Parks Spain Geographic Information System, and I go to this first URL. And here we can find this other link for downloading the data. Here we have the limits of the national park. And here in this URL right here, we can click and you see that it will start downloading the RAR file. And if you want to copy the URL, you can right click on it and copy the URL. And that's what I have here, which you can see that finishes in .rar. So here I'm defining the paths for downloading and unrar. So with strglue, I'm gluing the temporary directory, which I can paste here in the console, which is this one for this session. And I'm adding the base name of this URL, which is basically the last part after the final slash. So if I execute this and print this rar file variable, you see that we have the temporary directory and the name of this rar file. And then with strremove, I'm removing the pattern.rar. So I will paste this also in the console, and you see that it's the same, but it doesn't finish in .rar. So now with download file, I can provide the URL that I want to download and the destination file. And since we are downloading the RAR file, we need to give here the destination file, one file that ends also in .rar. And that's why we are using the first URL. And we need to use this binary mode. So I will execute it and you see that it's already finished. Now in the temporary directory we have that RAR file and we can use this archive extract function from the archive package to extract the RAR file. And the second argument is where we want to extract it. So I will execute this function and you will see that it throws an error. But we can ignore this because actually this function worked. We can check this by printing the directory tree from the destination directory, and you will see here the destination directory, and inside we have this limited red, which was inside the rar file, and when you see that inside that folder we have other two .rar files, and we want to extract also the files from this one. So here you see that I added this try function, so we will ignore the error, and inside this extract function I'm pasting a different directory. So I'm creating this one which has until here, so is this part right here, and then I'm adding manually this limited red folder right here, and then I'm adding this .rar file to extract, and I want to extract it again in the destination directory. So I will execute this, and now you see that it doesn't throw an error, and it's because I wrapped it into this try function to ignore the error, and now we can show again the directory tree. Now I will make this bigger, and you see that now we have this new directory with all these files here. And the one that I'm interested in is this limited png.shapefile. So here I'm pasting again all the destination directory plus this folder, which is here, and then the name of the file. And I'm using the readsf function to read this file. So now I can print it in the console, and you will see that we have a simple feature collection with 13 features, and each of them will stand for a different national park in Spain. And now, since we are only interested in Picos de Europa, we can filter in these national parks SF by using the d_num_park variable that we have here. So I will make this a bit bigger so we can see it. And there we have it. You see that it starts with Parque Nacional, and then it has the name of the national park. So I'm trying to detect in that string, in that name, the words Picos de Europa. So when I use this part of the code, we are filtering only one, and you see that this is in a projected coordinate reference system, and I will transform it to the world geodesic system because we need it to extract the bounding box in the next step. So I will execute this, and I will use MapView to visualize the national park. And we can see that we have it here. We can zoom out to see that it is correctly located in the north of Spain. Alright, so the next step is to get the cycling routes. And I will clean my window using Ctrl L. And we can use this function from the OSM data package, available features, and you will see all the features that are available in the API of OpenStreetMap. And in this case, the one that I'm interested in is route, and you can find it if you find the air, and you find it here. So now if I use available tags for this feature, you will see the different values that are available for route. And the one that I'm interested in is bicycle because I want the cycling routes. So now I can start an OpenStreetMap query by using the opq function, and here I need to provide a bounding box. And to extract the bounding box, we can use the stvbox function from the SF package to extract the bounding box of the national park. And if I execute only this part of the code, you see that it's a vector of 4 coordinates. And if you open the help of this function, you will see that here it accepts different values, and you can see that they are in the same order as this function gives. And that's something important to check. So when we use this function, we are just building a query. So I will make this smaller again. And then we are adding an OpenStreetMap feature. And we want the key of route and the value of bicycle. So if I execute this, we are adding this to the query. And when we use OSM data underscore SF is when we retrieve the data. So I will execute it. It will take a couple of seconds. And now if I print it, this is a special list. And you see that inside this list we have different elements right here. You can see a brief description of them also. And since these are lines, because they are paths, we are interested either on the lines or the multi-lines. The difference is that the lines, sorry, they are 233, so one same path might be split in different small paths, and that's something that is not very interesting for us because some of the paths they doesn't have the name and it would be challenging to detect them, so it's better to use the multi-lines. So here is how I extract them. So I will execute this, and now we have a simple feature collection with 16 different routes. And you can see here the name that in some of these routes it's the same name, but they have backward and forward path. So what I will do now is to combine them in one feature. And to do so, we can group by name. So when I do this, we have a total of 11 groups in this table of 16 different rows. So we have 5 that are repeated. And here I'm using the summarize function to summarize by group. And I'm creating a new geometry because this is the special column for the vectorial data. And what I'm doing is to modify it to create the union of the groups that have the same name. So when I execute this, we should have in return a table of 11 different groups. And those that are repeated, the lines will be united. So now if I print this object in the console, you will see that we have 11 and none of the names are repeated. And now we combined the geometries of them. The next step is to calculate the path length because we are interested on showing it in the interactive map. So we can do that by using the stlength function, and then we pipe it into the setUnits function to say that we want it in kilometers because by default it's calculated in meters. And then with this mutate, I'm creating a label to show, and here I'm showing the name, which is this one here, and then I'm adding an HTML break, which will break the line and write the following in the new line. And with this b tag, I'm writing this text in bold. So here I'm adding the length and I'm rounding it to 2 characters. And finally, I'm adding the km to specify that these are kilometers. So if I execute this and print it now in the console, I will actually use the glimpse function. You will see that now we have this format right here. But when we translate this to the interactive map, this HTML will be read as it should be. The last piece of data that we need are the landmarks. And if I print this part of the code in the console, you will see that for tourism we have many different values. We have 22, and we can pull that value column to see all of them. And here what I'm interested in are the viewpoints and the attractions. And as you can see, we can write 2 of them if we want inside a vector. And the rest of the code is exactly the same as we saw before. But in this case, since they are some points in the space, we are interested in the points. And you see that we have a total of 73. And now you see that the lines are null, we have 2 polygons, and the rest are null. So we are obviously interested in these points. So that's why we are extracting them here. And if I print this in the console and I find here the name column, we will have some of the names that are not available. So they are NA values. So what I'm doing here is telling this dataset that if this name is NA, so if it's NA, I want it to change the name to unidentifying. And in the case that this is not fulfilled, I want the name to be exactly the same as it is. So to showcase this, I will comment out this part of the code and I will show you how this will change. So I will execute it again, and now you will see that the third one is unidentified and the rest have the name that they had already before. So the next step is to use another if else to detect if in the name they have the word mirador, which in Spanish stands for viewpoint. So it will create a new column called type, and it will say viewpoint when it has the word mirador. And if it doesn't have the word mirador, it will classify it as other. And here you see that I'm using two different functions. This one is from base R, and this one is from the dplyr package. You can use either of them, they will have the same result. And finally, I'm selecting only two columns because I'm interested only in the name and in the type. So I will execute it and print it again in the console. And now we have the name and the type of this landmark. So now it's time to go to the last part of this tutorial, which is creating the map. And here first I defined a vector of two colors for the points that we created for the landmarks, one color for the viewpoints and another color for the rest. So here I'm using the MapLibre function from the mapgl package, and here when I define the style, I'm defining a Carto style. And Carto is another library that provides some tiles, and we can use it for free without using any API token. And here we have one of the tiles that are available. And if you want to know the ones that are available, you can write here something random, and the error will tell you the ones that you can use. And you see here Voyager, Positron, Dark Matter, and then again these three tiles without labels. Here I can zoom in and you can see how this tile look like. So here I will use Ctrl C to keep the Voyager style. Then I use the fit bounds function to fit the bounding box to Picos de Europa National Park, and I use the animate equals to true, so we see this nice animation, and now we are centered in the national park. Then I add a navigation control and full screen control. And these are these buttons that you can see here. One for making full screen, but for make this to work, you should open this in a new window. And then you have some zoom tools. And you have also this arrow in the case that you rotate the map, so you can head again to the north. Then I'm adding a fill layer, and this is the function that we use to add polygons to our map. And here we need to add one identifier to the layer, so this is one unique ID. Then the source of the data, which is the simple feature object. Then I set the fill color to be transparent. I will already execute this so we can see it. Then I need to set the fill opacity to 1 if you want to see the outline, which I set to color red. Then I add a line layer for the roots and I give it an identifier of roots. The source is the simple feature object again, and you will see that for all the layers these two arguments are mandatory. Then I set the line color to dark blue, I give it a line width, I will execute it so we can see it. There we have the lines. And then I added a tooltip, and in the tooltip I'm adding the label column that we created before in this data. I will print it again. And we have this label where we added the name of the route. Then we added the break with HTML. And you can see here in the name that then we have the kilometers in bold and also in a new line. And you can see this for all of the different paths. And you can see also that when I hover the different paths, you will see that they become red and they become also thicker. And this is controlled by this hover options argument, where you specify inside a list some arguments that are already inside this function. So I will open the help of this function with F1, And inside hover options, you can specify a list with any of these arguments that you see here. So now we will continue to the last part, which is adding, or sorry, not the last part. Now we will add the circle layer, which is used for points. And here the ID is landmarks. The source is the simple feature of the landmarks. I added a pop-up here instead of a tooltip, so I will execute it again, and we see it. There we have the points. So now if I want to see the text of this name column, I need to click on the point. Otherwise, I won't see it. But on the lines, we will see them only if we hover over them. It's not necessary to click on them. Then the circle opacity is the opacity of the outline, or sorry, the opacity of the interior. Then we have the circle radius, which is the radius of the inner color. The circle stroke color is the color of the outline of the point. The circle stroke opacity is the opacity of the outline. And then I also specify the width to be 1. And this 1 is added on top of this radius that we specified before. And finally, for the color, I need to use this match expression function from the mapgl package, and I need to specify these three arguments. The first is the column that we will map to this color. So we want to map the type column that we have here. So I will print it again to remind you that the type column is the one where we specify viewpoint or other. Then I need to specify the values. So here I use this sentence. So we get these two values by viewpoint and other. And sorry, this is here. And then in the stops argument, we need to specify a vector of the same length of this vector with the colors that we want. And I specify this vector here in the beginning. So now I will execute with the last part of the code, which is adding a categorical legend. And to add a categorical legend, I'm adding here a title landmark that we see here. Then the values that I want to show, which are these two words that I showed you before, viewpoint and other, so the unique values of this type column. Then the colors are the same that we used for the points here. I need to give it an unique ID. Actually, this is not mandatory for the categorical legend. And finally, I'm saying that I want circular patches on this legend. If I don't specify this argument, they will be squares. And finally, I added another map here where I'm using MapTiler instead of Carto. And for MapTiler, you need the API token that we saw in the beginning. Otherwise, this won't work. And if you want to see the tiles, you can again write something random here, and you will see the different tiles that you have available. In this case, I use the satellite, and I will execute it again because the rest of the code is more or less the same. I just changed the color of the lines. And here we have our final map. We can open it in a new window. And here you can play also with this edit, enter full screen, so now it will work. And you can zoom in, you can see the name of the paths, and if you use the right click button, you will rotate the map. And if you want to come back, you just go back, and in the case that you rotated it and you want to go back to the north, you can use this button here.